Hello. All right. I'm so ready. I'm so ready. Today's going to go way better than yesterday. I'm locked in. Let's do this. Number 136. Start the timer. Easy. Given a non-empty array of integers nums, every element appears twice except for one. Find that single one. You must implement a solution with linear runtime complexity and use only constant extra space. I was going to do that anyway. Okay. Only constant extra space. So the really easy thing to do, which is cheating, so this is not going to be my answer, would be to just count everything, and then for values in counter.values. I'm not sure if that's how you do it, but because counter is kind of like a dictionary, or items. Whatever. I'm not even going to do this. It would be to count them and see which one has two. But we're going to do this in constant time, or with constant extra space. That wouldn't be constant extra space because you'd have to go. You'd have to store each element again. It would be linear runtime though, but we're still not going to do it. So how can you check with constant extra space? So here's a way you could do it with constant extra space, but quadratic runtime, so n squared runtime. So let me write these other answers down. N squared time O1 space. For each element, find it again in the list. So it takes n to go through the list the first time, and it takes another n to scan through the list for each one. That would be slow. The other one we said was on time on space, and that solution is count everything, look at the thing that has a count of 1. All right, so what we're going for is on time O1 space, best of both worlds. I'm thinking it's going to be something like this, except we have a faster way to find elements again. Though it's kind of hard to think of a way to do that without having to remember what we've found so far. Every element appears twice except for one. Like I can do 2 passes over the list, but not more than that. I mean, I can do more than that, but I have to do a constant number of passes over the list. Trying to think of something where like you go over and for each thing you find it again, but you find it quickly. Like the obvious way to do that is each time you go over, you add it to a different data structure. And then once you find it again, you remove it from that different data structure. But you might end up storing everything in the data structure before you start removing everything from the data structure, if stuff is in an order like that. Okay, well, here's another solution better than what we've come up with so far. N log n time O1 space. This is not the answer because it's not linear yet, but sort, then iterate over duplicates will be next to each, will be adjacent. Right, so you can sort in n log n time, and then after you sort, you can just go through the list from left to right, and it's going to be ordered. Obviously it's going to be ordered, but all of the duplicates will be right next to each other, so you don't have to remember more than one thing at a time. Okay, so I'm thinking, let's see if we can adapt this idea, because we don't need them to be sorted, but having the same elements next to each other is nice. But it's hard to think of something else you could do that would have that same property. You also have to do it in place, otherwise you're going to be using O of n extra space. Is it just me, or is this not as easy as it sounds? It's probably just me. Struggling to think of a different way to do this idea that doesn't involve sorting. I don't know if that I don't know if that is the right way to do it. So in my head, I'm going through the different sorting algorithms and trying to see if there's one that I could nerf so that it's not as good as sorting. It's not as good at sorting, but it gives me a property that I can use, like it puts the identical elements next to each other. But I'm not coming up with anything. It, like, in my head, it seems like putting the identical elements next to each other is not something you can get without sorting. It's like a byproduct of sorting. It's not a thing that you can get while skipping the sorting part. So when you iterate over the list one time, there's some stuff you can do in place in on time, like finding the max, finding the min, finding if any individual element is unique. But I don't see how any of that helps. All right, what are the other typical ideas that could come into this? There's like dynamic programming or recursion. Is there any way to apply something like that here? Oh, you know what else is a crazy idea? I'm not sure how this would work, but no, I don't know how to apply this, but the thing I'm thinking is something like, okay, I've got a 3. If I subtract 3 from everything else, I'm going to be left with a bunch of random numbers and a 0, and the 0 is my duplicate. Doesn't make a lot of sense. I don't know how to make that work. Because for each number, you're either, if I want to like make my numbers all cancel out, I'd have to make half of them negative, but I don't know how to make half of them negative without storing which ones I've made negative so far as extra space. Because if I made half of them negative and then took a sum, the sum would be the number that I'm looking for. Oh. Oh. Wait. I don't know if this makes sense, but I'm thinking something like take the sum of the whole list. That's going to be equal to 2 times the sum of the duplicates plus the non-duplicate, right? Like not the sum of the unique duplicates. I don't know how to get to the non-dupe from that. I was thinking something like you take that, you divide this whole thing by the sum of the duplicates. It doesn't really work. I wonder if I'm onto something here with the sum though. I'm not seeing it. This is taking a really long time for an easy problem. There's got to be something obvious I'm missing, right? Or is it easy because you can cheat easily and disregard this condition? I'm trying to think if there's other properties of numbers, like if you multiplied them all together. I don't think so, though. If you take the sum and then you go back through and try to find which term was only added once to the sum, I don't know how that would tell you anything. Like, this idea seemed really promising, where you could in place match them up without necessarily sorting them. Like, the only guarantee you have is that the things that are next to each other are duplicates, but you wouldn't know where to put them unless you were also sorting them. there's a million n squared ways of doing it. Like you go through every time you find a duplicate, you remove it, but you have to pass over the list n times for all of those. There's no other properties of the numbers, like they can be anything, it seems like. Between 1 and 3,000. No. The list could be up to 3,000. The numbers could be between negative 3,000 and 3,000. I never noticed there was hints here. I'm not going to use those though. We just seem so close with this, but so far. Like, let me list all of the sorting algorithms I know. Quick sort, merge sort, bubble sort, radix / bucket sort. So radix sort would be cool. That would work, but it would take an extra n space. Like because the idea here is you keep like a hash map. And every time you find a number with whatever property, you put it in that space in the hash map. Usually when you're sorting, the property is that the nth digit is whatever, or the binary in the binary representation, or in whatever representation. But yeah, we would have to store stuff, so we can't do that. Merge sort also, you have to have a recursive tree. Maybe there's a way to merge sort in place, but I'm not sure how. I think there's a way to merge sort in place, but so with merge sort, you split the list in the middle. You sort the left half, you sort the right half, and then you interleave them into the new list. I guess you can do that in place. You can do that in place. But yeah, that kind of technique is going to be n log n no matter what it is I'm doing, because the log n is coming from the recursiveness of it, the fact that we're splitting and recursing. And that's the same for quicksort. So there's no getting rid of the log. Bubble sort is n squared. You go from left to right, and you pull along the number until you find the place where it's supposed to go, basically. But you have to do that n times. And this would work, obviously, because it's kind of the same idea as you pick the first number, you try to find its duplicate. Once you do, you remove it. And then you pick the second number, you try to find its duplicate, etc. But there's no way to do that without n squared. So maybe this is not a good idea. Though it seems really close, maybe there's no tweak to make it work. Is there a way to count stuff without having to remember stuff? I mean, you can sum stuff. But I haven't figured out how that helps yet. The thing I'm kind of wondering now is, is there a way to like partition the list in half where all of the duplicates go into the opposite partitions? I'm wondering if this makes sense, because now you kind of have a way to know where to put something. You remember an index. Oh, could this be it? You remember an index into where the last duplicate is. So you start with a 1, and then you go right until you find. So you have 2 indexes. The left one is a pointer into. No, this isn't going to work. Let me finish the idea, but I don't think it's going to work. The left one's a pointer into storage, basically. You're using the first half of the list as storage. The right one is the pointer, so this is like the storage. The right one is the search pointer, so you're using it to find duplicates. So you start it in the first spot of the list, and then you iterate from here to the right until you find the duplicate. Once you find the duplicate, No, this isn't gonna work. This is n squared. Once you find the duplicate, you like swap it with here. So here you would you'd move this here, you'd move this here. You'd move your pointer, your storage pointer up to here. But yeah, I could give you a list where when you try to do this, you are doing it n squared because your search goes through the whole list each time, and your storage goes up by 2 each time. This is just the n squared answer. How the hell? How the hell? And how the hell? On one space. I can't remember the numbers that I've found. If you can't remember the numbers that you found, how can you do this? If you could do something clever with a property of the full list that you can compute in ON, like the sum, you could do it. If you could do something clever with the using the list itself as your own storage, which is cheating, really. Like, I don't know that that should be considered constant space if you're actually using the space in the list. So I'm not sure that this one even is a real answer. I think Leetcode sometimes counts that as constant space, but I'm not sure that that makes sense. All right, I have to take a bathroom break, but I keep thinking about this. Okay. I've figured it out on the toilet. This is always how it works, but you just need to step away from the problem to get a new perspective. But check this out, and this is really cool. What I was trying to think of is, what kind of global property can I figure out that could tell me something about the odd one out? One of the things I've been trying to think of is, like, if I multiply them out, if I multiply them all together, then is there something I can say about the evenness of it or the oddness? Like, if I divide it by 2, I know that this stuff is divisible by 2, but this could also be divisible by 2. And so I was getting nowhere with that line of thought. Then I was thinking something around parity, like there's 2 of all of these things and there's only 1 of these things. So, like, I was trying to think, is there some way to make the things that come in pairs cancel each other out? And there is with XOR. So if you have a binary number and you XOR it with itself, the answer is going to be 0. Because the definition of XOR is that the answer is only 1 when the 2 inputs differ. So if you XOR all of the numbers with each other, the result is going to be the one that didn't get canceled out. So that's all we have to do. Return reduce from functools import reduce from operations. Is that what it's called? Import XOR. Let's zoom in here. Python from operations import XOR. That's not a thing. Python XOR. Operator from operator import XOR. Return reduce XOR nums. Literally just that. Submit. Okay. It's interesting I'm not beating 100%, because how are you doing better than this? Right? A 3-word answer. There we go. 0 milliseconds beats 100%. What a beautiful answer. And I see why they called it easy. It's not actually easy. Like, this is hard to figure out, but it's hard to say that a 3 symbol answer, a 3-word answer could be anything other than easy. That's cool. Next problem. 137, single number 2. Given an integer array nums where every element appears 3 times except for 1, which appears exactly once, find the single element and return it. You must implement a solution with linear runtime complexity and use only constant extra space. We're screwed, because that trick's not going to work. That trick doesn't work. So is there such a thing as a trinary, not trinary, but like a 3 operand binary XOR? No, that wouldn't make any sense. Oh, but I guess what do you call a, I guess it's trinary. If we did the trinary representation, does this make any sense? So if a number was trinary, so 0, 1, and 2, and you take 3 of them, I don't know. I'm trying to think of a way to adapt the trick, but the problem is the 3 operands, not the representation. There might be a way to do this. There might be a way to have some operation that makes the 3s cancel out. Like, what could I do where only if something appears 3 times does it cancel out? I might be onto something with this. Like, so what I want is something where this is always the case. So you could if you did like a sum with no carry, that would do it. In other words, like you take the sum mod 3 for each digit sum mod 3. And then at the end you would have, you'd have the one number that you didn't touch. It would remain untouched. Any number when you do this by itself is unchanged. Okay. Now, does this only work on the trinary representation? Yeah, I think it does only work on the trinary representation. So you would do from functools reduce, import reduce, return reduce whatever this function is we're about to define on nums. And this function takes 2 numbers and one, or let's just call it A and B, and it returns a number. It takes the trinary representation. So I think the way you do that is like int a comma 3, or maybe you have to turn it into a string. Let's Python int 55 3. No, but what if you do it as a string? How do you change the base of something in Python? I have to look this up. Python change numeric base. So I know about bin. What's the general way to do it? Oh, I guess okay. There's not necessarily a built-in way to do it, so we're just going to do it ourselves. Def base. We want to change, we'll go to base. N is an int. Base is an int. So we're returning to base a of 3, not plus. Yes, plus to base b of 3. All of this mod 3. And then, oh, this is returning in, what is it returning? It's returning a, maybe it has to be returning a string, and then this plus doesn't really work. Instead, you'd have to go for like character 1, character 2 in zip of to base a3 to base b3. Ret is some string, or like result is a string. You want to go backwards here because you're, actually it doesn't matter because, well, you do want to go backwards because you just need to make sure there's zeros. You have to make sure you have zeros. How many digits are these numbers? Up to 32 bits. Or up to, they can be negative also, that's annoying. Okay, let's take a step back for 1 second. Is there a way to do this without defining all our own stuff? Do I really have to convert to trinary? Or is the mod 3 thing enough? Because the thing is, I'm going to convert to trinary, do a sum mod 3, and then convert out of trinary. But I don't know if the converting actually... Oh, I guess it's a digital sum mod 3, so that's not the same as the sum of the overall number mod 3. Digital meaning like per digit. All right, so I think I have to follow through with this idea. It's just, there's a lot of annoying stuff to keep track of. So A and B are strings. Okay, yeah, let's just do this. And then here you're doing a result dot append. Result dot append C1 plus C2 mod 3, but the C1 and C2, we convert them to integers first. And then this thing needs to be a string. Let's just say result digits. No, let's make it a string. So you append a string to the end of this. Then at the end you have to reverse the result because I put the most significant digits. No, actually, I did this correctly. The thing I have to remember is must return 32 bits pre-filled with zeros. So this is in the right order. You just need to convert it to an int. And the way you do that is by saying base 3. This didn't matter here because a number base 3 and a number between 0 and 2 base 3 is the same as base 10. But here you return it as a number. Okay. Now we just need to implement toBase, and we need to make sure that it returns 32 bits. Okay, so how do you convert a number to a different base? So you get the first digit by doing the full number mod that digit, right? First digit equals n mod base. Second digit would be you want the remainder after dividing by that. So n divided by base, and then you take that. What do you do with that? So you divide the Yeah, I think you just take this mod base and you keep going. So Python has something called div mod. Div mod. I can't remember if it's built in or you have to import it. But this gives you, if you do n base, this gives you the division, so remainder, and it gives you the mod. So first digit equals like let's say ret is something, then while remainder, and we'll set remainder, it's already called n, so while n, we'll just reset n, reuse n, ret dot append mod, but it actually should come before, so, and append is not a thing you can do on a string anyway. Oh yeah, so you can't do this anyway. So this would be ret equals string of mod plus ret. Then at the end, we just have to make sure it has enough zeros at the beginning, which you can do with like zfill, python dot zfill 5. Yeah, zfill 32. That's exactly what we want. Okay. Return ret dot zfill 32. Oh, to do negative numbers. Let's just make neg equals n is less than 0, n equals absolute value of n, and then return like I'll add a this thing. If neg else empty string. Here, actually, let's just do it like that. Neg equals this if that else empty string, and then this can just be neg. Okay, this possibly works. Let's see what kind of bugs we have, because this is complicated. Less than is not supported between string and int. We're passing a string to 2base. No, we're not. Where is how is n ever a string? How did n never become a string? What's the... Oh, well, this should be b, but that's not the problem. I'm going crazy. How is n a string? I guess I'm not passing my starting value here, but why would it start as a string? That's not the place I meant to put it. I meant to put it here. Oh, reduce starts it as a string? And I'm getting the right answer already. I really had no other bugs. Well, let's see about that. My ability to hide bugs is unmatched. Oh yeah, negative numbers. That's... So toBase is returning a string that could have a minus in it. And I'm not really handling that properly, actually. But you know what? It doesn't... I was going to say it doesn't matter. In a way, it doesn't matter, and I could just treat minus as a extra bit. But I have to recover it at the end, so then I'd have to convert the extra bit back to a minus at the end, which I can do. I wonder if Python has a way to just give me the bits, you know? Like, I don't care if it represents a minus, just give me the bits, and then just convert it back into an integer at the end. I guess there's like 2 bytes. Python 55.2 bytes. Or is it like bytes of 55? But when it tries to... How do I convert that? Can I just convert that to an int? Base 3? No. Okay. All right, well, I think let's just treat the negation as an extra bit on the front, which it is in a way. Like a 32-bit integer is a 31-bit integer and an extra bit on the front that tells you whether it's positive or negative. So I think I can just do that. Treat it like... This is basically me saying it's just bits, bro. And then you can just sum it as bits. And then the only thing is at the end, I'm going to have to convert the first bit back into a minus sign. So ret equals this. If ret is greater than basically if I have a bit in this position, I guess the other way to say that is if ret shifted to the right by 1 ANDed with a 1 is true, then I need to remove that bit and make it negative. Then ret equals, how do I remove a bit from the front? So I could do mod and then this number, 1 pushed left by 31, or 32 actually. Can you do mod equals in Python? A equals 6, A mod equals 3. A equals 7, A mod equals 3. You can't. Okay. Okay, we're doing some bit manipulation here that I'm not necessarily comfortable with, but we'll see. So you remove the bit and you make it negative. Ret equals negative ret. Then you return ret. I'm off by a bit. A literal bit, not by a little bit, because I'm off by a lot. I managed to make it negative. I think I screwed up in taking the mod. Does this need to be push left 31 instead of 32? Let's print some stuff. Print bin of ret. Print ret shifted right by 31. So in these cases, there's no extra minus. In this case, wait, why is this such a huge number? Something else must be going wrong. Because it shouldn't be, this number should be like 4 and then a bunch of zeros and then a 1 on the end. So how am I getting such a crazy huge number? I guess we can print A and B here. So B's negative, so it ends up getting a -1 up here. Excuse me. which makes sense, but then is my result? Oh. Yeah, my result's not going to make any sense because now I'm adding the negative bit. As though it's a real thing, though I am modding it. So it should never get out of control. Like, it should be able to get to 1, 1. No, actually, it should only be able to get to 2. This should be the number 2, not 1, 1. How can it get to 1, 1? Oh, maybe I do need to zfill 32 because I'm seeing there's an extra 0 before this 1. Where's the extra 0 coming from? I'm just trying stuff now. Okay, 31's the number I think it's supposed to be. A 1 at the front means negative. Oh, I guess like this is 32 bits, but I'm returning a trinary number, not a binary number. So this is going to be way bigger than it needs to be, which is fine. That's like all the more reason why it shouldn't conflict with the with the rest of the sum. So A starts at all zeros. This B is the first number in the list, which is -2. So it's 1 to represent the negative, a bunch of zeros, and then a 2. And then it says the result of that is a -2, which is right. Then, is this the same? Yeah, so then we added an extra 0 to the front for some reason. when we went when we converted it back, I guess at that point it's not a negative number anymore. It's just a number with a 1 really high up. Which is kind of weird. I don't know where the extra 0 comes from. But we keep getting more zeros. Or, I mean, we keep getting more 1s. Something's not working with my conversion between base 3 and base 10. I mean, what if I just kept everything in base 3 until the end? So, so my left side is a base 3. Which means my 0 here should be a base 3 number. Basically 0 times 32. You don't have to convert A to base 3. It's already base 3. You do have to convert B. And then your result should not be converted. You're returning a string. Then at the end, you have to convert this into a non-base 3 number. Just so we're doing less converting around. That looks better. Okay, then we can't do this bit stuff because we're dealing with an actual string. So let's do it at this point here. Base 3 result. Let's turn it back into negative if it's negative. So if the 32th thing is a 1, and it can't be a 2. There's no way for it to get to a 2. Then remove that bit and Yeah, just remove that bit and then convert it. Oh, it's not the -1, it's the first result. Or it's the first bit. Oh, and remember that it's negative. So just do this, actually. Return, skip the first bit, and make it negative. Submit. Ta-da! Okay. So, you know, we did it. It's linear time. It's 1 extra space. I mean, you know, yeah, 32 bits of extra space. And not even bits. It's more than that because we're storing stuff as strings and stuff. I bet there's a number theory way to do this better than how we did it, and I am curious how people did it. Just show me the code, man. Interesting. Yeah. So it's this is interesting. I think I'd have to think about it a little longer to fully understand why it works, but it's a different extension of the first solution. One line. No, this is cheating. Set of numbers is O(n) space. Set of numbers, that's O(n) space. Cheating. Everyone's cheating, huh? This is the other trick that I didn't quite get. You're keeping track of... Like, this is the same as what we were doing before. This thing with the not 2s and not 1s. I do not quite understand, but I see why something like that would work. I haven't seen anyone... Well, this is cheating. This is cheating. I haven't seen anyone do the trinary solution yet. So I think maybe we have something... This is cheating. Maybe we have something unique here. Trinary? Or is it called ternary? ternary. I've been saying trinary. Worse than 90% fire. That's mood. Yep, this is what we're doing. They managed to like figure out the bitwise stuff better than we did. So they're not even working with strings. They're just doing it properly. Yeah. What is this? What? This guy literally copies homework into the solution? Okay. Next problem. That was cool. 138, copy list with random pointer, medium. A linked list of length n is given such that each node contains an additional random pointer, which could point to any node in the list or null. Construct a deep copy of the list. The deep copy should consist of exactly n brand new nodes, where each new node has its value set to the value of its corresponding original node. Both the next and random pointer of the new nodes should point to new nodes in the copied list, such that the pointers in the original list and copied list represent the same list state. None of the pointers in the new list should point to nodes in the original list. For example, if there are two nodes x and y in the original list where x.random goes to y, then for the corresponding two nodes x and y in the copied list, x.random goes to lowercase x.random goes to lowercase y. Return the head of the copied list. The linked list is represented in the input/output as well as list of n nodes. Each node is represented as a pair of val, random index, where val an integer representing node.val, random index, the index of the node ranging from 0 to n-1 that the random pointer points to, or null if it does not point to any node. Your code will only be given the head of the original linked list. So I don't see how random is making this any harder. Because this is basically the problem from last time of you get a graph, copy the graph. I guess if, like, this is very easy to do with O of n extra space. And I don't really see how you're doing any better than that unless you're cheating by like modifying the original list to remember where the nodes should go, basically. So I'm just going to do it with O of n extra space because I think that's the best you can do it, other than like cheating. But it didn't say anything about that. Okay, so basically, it's too simple, but I'm just going to do it. For current equals head while current equals current.next. That's how you traverse. Then we're going to say copies equals a list. Copies.append node val equals current.val. We're also going to keep track of pointers. Which is going to be, so copies is going to be nodes, list of nodes. Pointers is going to be tuple of int that tell me where to point stuff. So now that I'm doing it, they probably don't want me to use this extra space. So let's just finish this and then see if we can do it without using up the extra space. So add the node and then add the pointers. Pointers.append current.next.val and current.random.val. And then we just iterate through the list and build like set up the values. So for I in range len of copies, copies of I dot next equals copies of I plus 1 dot next. Yeah, I don't even, so I only need the random pointers here. Randoms. Don't need tuples, I just need ints. Because they're already going to be in order. If I is less than len of copies minus 1, and then unconditionally copies of I dot random equals randoms of I, then just return the first thing. So this will work. It uses a bunch of extra space. Init got an unexpected keyword argument val. What are you talking about? That's, oh, they called it X? Why did they do that? I changed this to be called randoms. Oh, random can be none. Okay. If current.random else none. That's weird that it ended up not connected to anything. How can that be? Oh, I didn't mean to do that. I meant to do this. Random pointer of node with value 13 points to a node not in the copied list. Oh yeah. Because this should be an index into copies. If it exists. if it is not none, because it can be 0. How can it be? Oh, is it because the values are not in order? No, the values are not in order. Actually, I don't know why I thought they were. Maybe that's where the challenge is. So, not in trying to use less space. So copies. This is not an index into the copy. Randoms is the actual value. So like the easy thing you can do is values to index is a dictionary, and then we just create it. So for I in range len of copies, copy copies of I dot val maps to I. And then over here, I can say this is my index, and then I grab copies of index. Yeah, that's not how you do that. You close that, and then you do equals I. So my random index is not pointing to the right. Oh, that's because randoms of I is the value. So if the value is none, how am I ending up pointing to the wrong thing? Not just like none or something. I'm having trouble seeing how I could even be doing that. So this is supposed to be the random pointer, right? Yeah, random index. Random index, the index of the node that the random pointer points to. And I'm saying you should be pointing to the last thing in the list. Which is wrong. Oh, wait. Can more than one thing have the same value? Why not, right? More than one thing can have the same value. So this, what I'm doing makes no sense then. Okay, so the question is, how do I know which node I'm talking about in order to copy the random? So one way to do it is to have a map that maps node how do I say this? Like, this is my problem. It's not enough to grab the value of the random node. I have to know which node it's actually pointing to. So how could I know which index it's pointing to? One way is I could just iterate over again how do I know which index it's pointing to? So I've got the list. In the original list, it's pointing to this random node. I haven't necessarily made a copy of it yet. Maybe if I made a list of the original nodes, originals equals list of node. Originals dot append current. So now I've got the originals. Now if I current equals head, start over, my won't need that anymore. While current, start over the loop. So I've got yeah, I can do the copies up here. And I don't need to iterate like that anymore. I can do for I in, let's delete all this. For I in range of len of copies. So copies of I dot next equals copies of I plus 1. If you can do that. If copies, if I is less than len of copies minus 1. And then the randoms, copies of I dot random, is basically look at the originals of I dot random original random. Like you have this, and then you want to know where it is. So we want a thing that's like original to index of that. And that's going to be our index, and then we can do copies of index. So original to index is a dictionary from node to int. Original to index. And I'm not, am I using originals? I guess I am. Original to index. Original to index. It takes at the value at current. It has an index. We'll have to do I equals 0, I plus equals 1. This is a type signature, not a value. Same here. Yeah, random could be none. So if is not none. Okay. Oh, stupid empty list. If not head, return head. Return none. Boom. Very good time. That's interesting. Why is it so good? That's cool. I wanted to think for a second what can be done better here. Like, do I need all of this stuff? Seems like I do. Let's see whether someone has something revolutionary. Probably not. They have less stuff than me. Oh, actually, yeah, that's clever. So they only have one hash map. That's nicer than this. They don't need to store like they're storing the same amount of stuff, I think. It's just that they don't need a list to hold this, because they can just instead of mapping this, it could be a node to node map. They don't end up needing to have 2 copies of the nodes, because they're setting the next as they go, so they never have to index into the original. That's cool. That is a little better. I mean, it's the same runtime, but it's a nicer way to write it. Next problem, 139, word break medium. Given a string S and a dictionary of strings word dict, return true if S can be segmented into a space-separated sequence of 1 or more dictionary words. Note that the same word in the dictionary may be reused multiple times in the segmentation. Leetcode, leet and code, you just return true if it can be. I'm getting palindrome word ladder flashbacks. All right, so the first idea that I can think of, obviously, is try every split. That's going to be O of 2 to the n number of splits times. It depends how you find if a word is in a dictionary. But if it's stored as a set and you can check in O1, you can do that, and you may have n separate words, and you can check if each one's in the dictionary in O1 time. Some immediate thoughts. We can backtrack early when something is already not in the dictionary. We can store our dictionary in a complicated is it called a Huffman tree or a trie? In something that will tell us whether we're on the way to being a word, so that we can more quickly so that even if we're not, so that we can check a partial solution basically faster without having to generate a whole word. We only have to return true, right? Yeah, we only have to return true or false. So I'm trying to think how to combine these different random thoughts I've just spewed into an algorithm. So we can do something like, actually we can do, does dynamic programming make sense? It's like, you know, if I is an index into the string, can you make words out of the strings starting at I? Right? Do from functools import cache. Add a cache on there. Now it's technically dynamic programming. So you want to know, is my prefix a word? For each one, is the rest doable? A different way to do this is to go letter by letter and say, is this letter in the trie or the Huffman tree or whatever it's called? I think that ends up being the same, actually. Okay, so I think we can quickly go from here's my string to where are the ending prefixes? Or like ending indexes. Where can I go? What words start where I am and end somewhere? And where is that ending? And then for each one, we recurse on the remainder. So the way you do that is by well, let's do it the slow way first. So it's like for I in range. Let's do a little bit of pre-processing. Longest word for max word length equals max of word dict key equals len, and then len of that. So for every word length, am I a word? Let's also words equals set of word dict. Let's also store that so that we can quickly check if something is in there. Okay, for I in range max word length, if I don't really need substring, I'm just going to use s of starting at I. If s starting at I in words, starting at I and ending at, I'm using too many i's, so starting at I and ending at j, if that's a word, recurse. So now you start at j, or I plus j. Yeah, you just start at, you start there. If any of these are true, you return true. So return true. If none, then you return false. What's our base case? If I equals len of s minus 1, return true. So you managed to get to the end. Return rec of 0. Any chance? Any hope? We said false for Leetcode. Print I, j, s of I, j. I plus j is what this should be. We still said false for Leetcode. Let's print some stuff. So what kind of strings were we considering here? I see. So we don't care about words of length 0, and we do care about words of length all the way up to and including max word length. So we did try Leet, we did try code. You know what? This should be equal to length. That's when you know you've gotten to the end. You don't want to be on the last character. You want to be at the exact end. And if you're further than this, you want to say false, because, well, you can't even get to that, actually. Well, you could, actually. You could, but then you do want to say false, and we will say false. So let's submit that. We'll say false because we will iterate over nothing and then say false. Okay, good. I think we can do better, honestly. Oh, well, first of all, we can not print. I think we can more quickly... Okay, well, you can't do better than 100%. But I think in theory, you could more quickly jump to words without having to go through every length of word, although not really, actually. You can't really do better than this. Other stuff that would theoretically make it better is unroll the recursion, go from right to left. The recursion is making me store an extra log n of space as we go down the recursive tree. Actually, it's not necessarily log n. I don't know how deep the tree can be, but we're storing extra space. We're storing extra log, we're storing extra n space. We're already storing n space for the cache, and we're storing an extra n space for the recursive, like, memory, the stack memory of remembering where we are in the recursion. And we could get rid of that and just unroll the thing into a dynamic program. But we're already at 100%, so we don't need to do that. Next, word break 2. Oh boy. Oh boy, I feared this. Number 140, word break 2, hard. Given a string S in a dictionary of strings word dict, add spaces in S to construct a sentence where each word is a valid dictionary word. Return all such possible sentences in any order. Note that the same word in the dictionary may be reused multiple times in the segmentation. You know what? I think our last solution can immediately be used. I don't see why not. Here, instead of returning true, you return an empty list. Each solution is a string, so you return an empty string. Here, instead of returning true, we want to gather up all the solutions. We're appending something. We're returning ret. This is not returning bool, this is returning a list of strings. I'm foreseeing that I may run out of memory with this idea, though I'm not sure, because the solution is also going to be huge if I run out of memory. Okay, so what am I appending? I'm appending the prefix, which is this, plus a space, plus the result of this. If I let's put a max on this. We don't want J to go farther than the end of the word, because I don't want to have to handle a different base case. So what would be the end of the word? So length of S is the end, minus I, because we're doing I plus J. And then I think I don't need an extra -1. I don't think I need an extra -1 because it's in a range, so it's already not going to take the top range of it, the top end of it. Okay, and then this is what is this? Rec is supposed to return a list. So it could be an empty list, or it could be a list with something to append. If there is anything, so I'm going to do this walrus operator here so that I can do it in line. It's not, you can't append rest because rest is a list. So you have to iterate for rest in rests. You append this prefix plus one of the solutions. Okay. You can't use the assignment expression? Is that, can I, if I put it in parentheses, does it let me? It does. Okay. I'm adding a space on the end. That's true. If rest, then you do that. Else, you don't add the space. Let's submit. 0%, 0 milliseconds, 100% in 6 minutes and 28 seconds. Not too shabby for a hard problem. All right. I suppose that makes us the champions, and now we can we can get the job. We got the job. We passed the interview. So good job us, and that's gonna be all. Please leave me a like on Leetcode or on YouTube if this was helpful. Bye.